Hello, math people. Today in Math 3, we're going to look at factoring polynomials in 3 different ways. The first thing we're going to do is factor a GCF. Then we're going to factor the difference of two squares. And then we're going to factor a special type of trinomials. So let's start with factoring the GCF. By the way, when you're factoring, is there a GCF is always the first question you should ask. Is there a GCF? So a GCF, the greatest common factor, is a number, the smallest number that goes into both terms, or all 3 terms. So for instance, if we look at 3 and 9, we may intuitively see that 3 goes into both 3 and 9. So we can write 3 as 3 times x, and we can write 9 as 3 times 3. So we see that they both have a 3 in common. So what we're going to do is we're going to take out the 3 they have in common. We're going to factor that out. And then we write what's left. And so what would be left would be x plus 3. Now, you should never get a GCF problem wrong because you can always check your answer. How do we check our answer? Simply distribute the 3 back into the parentheses and you should get what you started with. So if I were to multiply this out, I get 3x plus 9, and ding, 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 that's what I started with, okay? All right, let's do B. So for B, what is the greatest number that can go into 15 and 25? And so yes, you are correct, 5. So this is 3 times 5 times x plus 5 times 5, x times x. So we're going to see everything they have in common. They do not have a 3 in common. Why did I? They have a 5 in common. They have 1 x in common. So everything they have in common, I'm taking out. What's left goes back into the parentheses. So what's left here is a 3. What is left here is 5x, and that's my answer. And again, just a quick check of that, if I were to multiply this back out, I get 15x plus 25x squared. Okay? All right, let's do C. Now C, they do not have a numerical GCF. There's no number that goes into both 1 and 7 other than 1. But what do I do with the x's? So I have 4 x's here, minus 7 times x. So what do they have in common? They have an x in common. What else? There's another x in common. So I'm going to take out what they have in common, which is x squared, and write what's left, which would be x squared minus 7. Okie dokie? Okay, boys and girls, what I would like for you to do is I would like for you to pause the video and then come back and check and try these 3 and then come back and check your answers. Okay, welcome back. And we're just going to quickly go over the answers. For this one, we should have 9x squared. And when everything is simplified, when everything is factored out, when everything is canceled out, a 1 is left. So make sure you leave a 1 there as a placeholder. Because again, when I multiply this through, I have to go back to 9x squared plus 18x cubed. Okay, what do they have in common? Notice that the 8 has no x, so we can't take out any x's, but they each have a 2. So I'm going to take out a 2, and I have x cubed minus 2x squared plus 4. And on the last one, they have 5x squared in common. And remember, when everything is factored out, when everything is canceled out, a 1 is left. And that is how we factor using the greatest common factor. Okay, now boys and girls, now we're going to learn to factor using the difference of 2 squares. I call these dots, difference of 2 squares. In order for it to be a dot, you have to have 2. It has to be a binomial, 2 terms. There has to be a subtraction for the difference, and both numbers have to be perfect squares. In this video, I've already written the most common perfect squares, 1 through 16 and then 25. You may want to pause this video for a second so that you can write down these perfect squares. Okay, welcome back. So the formula for the difference of two squares is this. If I have two perfect squares, then I can factor them by saying a plus b, a minus b. What does that look like? Let's do some examples. In this case, I have two perfect squares, x squared and 16. They're both the perfect squares because 16 is here. They're both perfect squares. So this is x times x, and this is 4 times 4. So a is x, b is 4. So therefore, we're going to have x plus 4, x minus 4. Now, could I write that x minus 4, x plus 4? Absolutely, because of the commutative property of multiplication. All righty? So in b, I have x times x and 121. If we look at our handy-dandy chart, we see we have 121, and it's 11 times 11. So again, my a is x, b is 11, so I can write this as x minus 11. I'm just going to do it differently just to freak you out there. Okay? For c, we have 36. So this is x times x and 6 times 6. And so I can write this as x plus 6, x minus 6. Is 49 a perfect square? You betcha. 49 is a perfect square because it's 7 times 7. So then I can write x plus 7, x minus 7. Okay, pause the video. Well, let me do another one with you with e because it is a little different. Now we have a coefficient in front of x squared. Does that change anything? Not really, because 16 is still a perfect square. It's 4 times 4. So this is going to be 4x times 4x. 9 is a perfect square. It's 3 times 3. So this is going to be 3 times 3. So then my answer is 4x plus 3, 4x minus 3. Okie dokie? All right, boys and girls, pause the video and you do F, G, and E. Okay, welcome back. So let's get this started. I'm just going to do them for you. 7x plus 9, 7x minus 9, 5x plus 13, 5x minus 13, and this would be 2x plus 25, 2x minus 25, and those are our answers. Okie dokie, boys and girls. Now we have one more type to learn, and this one requires a little bit of work. So I'll tell you what we're going to do. We're going to end the video here, and then we're going to come back and finish it with the trinomials.